everyone, welcome back to my YouTube channel. In this video, I shall explain on how to answer Hess Law question. So let's get started. Carbon monoxide is an important industrial gas used in the production of various chemical processes. Using the thermochemical equation provided, calculate the enthalpy change for the formation of carbon monoxide from graphite and oxygen gas, given that the thermochemical equation are as follows. The first thing that you need to do in order for you to answer this question is to write a balance equation for the target reaction. So the target reaction states that you want to formulate carbon dioxide from graphite and oxygen gas. So graphite, which is solid, plus oxygen gas will produce carbon monoxide, which should be in a gas form. So this is your target equation. But first and foremost, you need to make sure that this equation is balanced. So carbon monoxide only have one carbon and one oxygen. So you do have one carbon, but you have excess amount of oxygen here. So you need to put half around here. So this is your balance equation. Alright. So next up, you need to make sure that you use all three equations that is given to you. For example, if you're given 5 equations, you need to use all 5. You cannot choose whichever equation that you want to use. So let's look at the first equation. You have carbon and oxygen gas to produce carbon dioxide, right? So the first thing that you need to do is you need to make sure that the location of all the elements are at the correct place. So for example, the first equation, we do need the carbon and oxygen, but we do not need the carbon dioxide. That's fine, but make sure that we have enough, right? So carbon and oxygen, and then we have carbon dioxide. So what do we need to do is we need to, because if you just have one oxygen there, it won't be enough. So the easiest way is we need to times 2. Right. So let's move on to the second equation. So for the second equation, we have carbon monoxide at the reactant. So we need to switch. Right. So for the last equation, we have carbon dioxide. Fine, and then it will produce the carbon and oxygen, right? So although this one, it seems weird, it is not at the correct position, we are going to just leave it as is, because later on you can see how are we going to find the excess amount of carbon and oxygen that we need to omit. All right, so now what I'm going to do is I'm going to rearrange and rewrite this equation so that we can see it clearer. Alright, so this is our target equation. So I'm going to start with the first equation given to you, which is carbon plus oxygen gas will produce carbon dioxide with delta H is equivalent to negative 393.5 kilojoule per mole. Right. So what I'm going to do with this is I'm going to times 2. So when I times 2, you will get 2 carbon plus 2 oxygen gas to produce 2 carbon dioxide gas. Therefore, your delta H, you need to times 2 as well. It becomes negative 787.0 kilojoule per mole. Alright. So let's move on to the second equation given to you. So the equation is carbon monoxide plus half oxygen gas to produce carbon dioxide gas with delta H equivalent to negative kilojoule per mole. So now what we are going to do is we are going to switch places. So whatever in the product you change it to the reactant. So we have carbon dioxide gas. So now it's going to be carbon monoxide gas plus half oxygen gas. So your delta H from positive, you need to change to negative because we swap the location of your reactant and the product. So the third one is carbon dioxide will produce just carbon and also oxygen gas with your delta H equivalent to positive 393.5. So this equation, I'm not going to do anything. I'm just going to leave it as is. So make sure for Hess law, if you're given 5 equations, you need to use all 5. And for instance, this question, we have been given 3 equations, so we need to use all 3. So our target equation is this one. So you need to make sure that all these 3 equations you can slash out until at the end you will get your target equation. So the first thing that we do not need is not related to the target equation is carbon dioxide. So the first equation we have 2 carbon dioxide. So here we have 1 carbon dioxide and the other 1 carbon dioxide. So this one is no longer available. Alright, so next we only need 1 carbon, but here in the first equation we have 2 carbons. So we have another carbon here, so we can slash out this one. Okay, next up we only need half of oxygen, right? So we have 2 oxygen here in the first equation. So if we slash out this one, you will end up with 1. And then we have another half oxygen here, so you will end up with half oxygen, right? So the only thing that you are left here is we have carbon and then we have half oxygen. So there's nothing else in the reactant, and we are left with this carbon dioxide gas, which fits the target equation. So this equation fits this equation. So what we are going to do with the delta H is we are going to do the summation of all this delta H, right, to get what is the delta H. So now your delta H should be equivalent to the summation of all the H. So negative 787 plus positive 283 plus positive 393.5. So you will end up getting 110.5 kilojoule per mole. So this one should be negative. So this is the final answer for this question. Thank you very much for watching this video from the beginning till the end. So I'll see you again in the next video. Goodbye.